this, we are discussing about the soil and pollution, chemical toxicology, the state of global environment. So these topics we are discussed in this elective paper. So here the first chapter is Introduction to Green Chemistry. So in this, what is the introduction? What is green chemistry? And what is the need for green chemistry? And what are the goals of green chemistry? And what are the limitations in this green chemistry? So these terminologies we are discussed. So here, what is the introduction? So this green chemistry is the branch of chemistry which deals with the study of design of products and process that reduce or eliminate the use and generation of hazardous substances. Green chemistry deals with chemical synthesis, which are being, it involves reducing cost, energy, impact on environment, toxicity, materials, including plants, waste, risk, and hazards. Okay. So what is green chemistry? So this is a special type of chemistry. We can design a chemical product in the green synthesis. In this process, we can avoid some of the hazardous substances, and using this green chemistry, we can save the cost, energy, as well as environment, toxicity. Okay, the using of the waste should be degraded by using this green chemistry. Let us discuss what is green chemistry. The green chemistry is the design of chemical products and process that reduce or eliminate the use or generation of hazardous substances. Green chemistry applies across the life cycle of a chemical product, including its design, manufacture, use, and utility. Disposal. Green chemistry is also known as a sustainable chemistry. So what is green chemistry? So by using this green chemistry, if we can prepare a complex or if we can prepare a compound, so that compound, the design, manufacture, and utility disposes are very different for the other preparation methods. Okay. So by using this green synthesis, we can get the atmospheric, we can take the atmosphere as it doesn't having any pollution, or we can avoid the pollution. What is the need for chemistry? The chemistry has improved our quality of life and made thousands of products possible. The 20th century has been highly successful in this regard. However, with the advent of the 21st century, the public is equally aware of the hazardous substances used and generated by the chemical process. Our environment, which is included by name, need to be protected from ever increased chemical pollution associated with the contemporary lifestyle and the emerging technologies. Then what are the goals of chemistry? The first one is prevent the pollution at the molecular level. That means if we can prepare the tablets, whatever it may be in the industry, it can release some of the gases or some of the waste material dumped into the rivers or seas. At that time, river, that means the atmosphere as well as the earth can get some of the pollution. Okay, so if we can do the experiment by the green synthesis, we can prevent the pollution. The second point is that is a philosophy that applies to all areas of chemistry, not a single discipline of chemistry. Applies innovative scientific solutions to real world environment problem. Results in source reduction because it prevents the generation of pollution, reduces the negative impact of chemical products and process on human health and the environment. Lessons and sometimes elements hazardous from existing products and process. Design of chemical product and process to reduce their intrinsic hazardous. Okay, if we can change the design of the chemical. At that moment the hazardness should be decreased. So that's why we can modify the structure. At that moment also we can avoid the hazardous products. What are the limitations of the green chemistry? Okay, so the limitations are that the first one is availability of green technologies. We still do not have viable green chemistry based solution for many chemistries or processes like nitration, sulfonation, Friedel-Crafts alkylation, acylation, etc. In the absence of such solution, the industry does these chemistries with conventional ways using huge quantities of acids, alkalis, and other hazardous reagents. So the availability of green, suppose we can prepare the nitrobenzene. In this nitrobenzene preparation, we can take the concentrated nitric acid and concentrated acetic acid. So they can release so many fumes. So that get some of the difficulty to the environment. Scale up and commercialization. These are many inventions that have already been developed by various academic and research institutes, and these are potential solutions for some of the environment challenges faced by the industry. The third point is connecting green chemistry solution provides to industry. These are many green chemistry solutions that are ready and are proven. One of the key limitations is the communication gap between the industry and such solution provides. So this could also be due to industry not putting enough efforts to search and look around this pollution. That means if some green chemistry solutions are there, so the industry could not put efforts upon these solutions. So due to that reason also, they could not, this is one of the limitation of the green synthesis. Understanding, the next one is understanding of basic principles. So what are the basic principles? One of the limitation implementation of green chemistry is that our team of chemists and chemical energies working on designing new products and process have limited knowledge and about the basic principles of green chemistry and engineering. Next point is green chemistry is costly, complex, and not available for SMEs. The next is regularity hazardous. So these are the some of the limitations of green chemistry. Then The next chapter is principles of green chemistry. So, how many principles are involved in green chemistry? Generally, these 12 principles are the most important is in the examination also. The principles of green chemistry, it is one of the important question. So, what are the principles are there? The first principle is that prevention of waste or byproducts. The second principle is maximum incorporation of the reaction into the third principle is so here principle. The third principle is prevention or minimization of hazardous product. The fourth principle is designing of safer chemicals. The fifth one is energy requirement for any synthesis should be minimum. The sixth one is selecting the most appropriate solvent. The seventh one is selecting the appropriate starting material. Eighth principle is use of catalyst should be preferred whenever possible. Ninth one is products obtained should be biodegradable. Tenth one is use of protecting group should be avoided whenever possible. 11th one is the manufacturing plants should be so designed as to eliminate the possibility of accidents during operation. Strengthening of analytical techniques to control hazardous products. So here, the first principle is that prevention of waste or byproducts. So here, by using this, designing a green synthesis and prevention of waste or byproducts, how we can prevent the waste or how we can prevent the byproduct. Okay, it is the most advantageous to carry out the synthesis in such a way so that the formation of waste is minimized or absent. It is especially important because in most of the cases, the cost involved in the treatment and disposal of waste adds to the unreacted starting materials form a part of the waste. The formation of the waste should be avoided as far as possible. The waste is discharged in the atmosphere, sea, or land, not only cases of pollution but also require expenditure for cleaning up. So here, if we can prepare a complex, in this complex, A is reacted with B and it produces C, as well as it produces a D of byproduct. So that byproduct, it is dumped into the atmosphere or sea or land. So at that moment, the atmosphere, land, or whatever, the cause the environment problem. And the cleaning of the waste should be takes more time. Okay. So that's why we have to take the product, the complete, we can take the reactant is converted to product. It could not or it could not produce the byproduct. Then only this reaction, it is called as green synthesis reaction. Let us take the maximum incorporation of the reactant into the final product. That means the reactants are converted to product. Then at that moment we could not get the byproduct. So that's why that reaction is called as green synthesis reaction. For example, we can take addition reactions, rearrangement reactions. So in this two reactions, these all the reactions also there. So in these three reactions, all the reactants are converted to products. They could not release any byproduct. So that's why if no byproducts are produced, there is no waste. So that's why they could not get any pollution. So that type of reactions are called as green synthesis reactions. Let us take, by using this principle, we can calculate the atom economy of the reaction. By using the atom economy, we can explain it is the green synthesis reaction or not. Okay. So you can look at this third para. The chemists globally consider that if the yield of the reaction is about 90%, the reaction is good. The percentage yield is calculated by, here look at this, this is the percentage of yield. The percentage of yield is equals actual yield of the product by theoretical yield of the product into 1000. So here into 100. So if this percentage is equals to 90, it is called as a green synthesis reaction. Not only by taking this principle, another one is there, that is the reaction. By using the reaction, we can explain the atom economy. That is, the reaction or the synthesis is considered to be screened if there is a maximum incorporation of the starting materials and the reagents in the final product. We should take into account the percentage atom utilization. So the percent of atom utilization, by using take this principle also, we can calculate the atom economy. So percent of atom utilization, that is equals molecular weight of desired product by the molecular weight of desired products plus waste, or that is called as byproduct, into 100. By using this formula also, we can calculate the atom economy. And it is having another formula. This is the most useful formula, that is percent of atom economy is equal to formula weight of atoms utilized by formula weight of reactant used in the reaction into 100. So by using this reaction, we can calculate the atom economy of the reaction. Look at this, the rearrangement reaction. This is the best example. In this rearrangement reaction, allyloxybenzene at 200 degrees centigrade, it is converted to 2-prop-1. It is called as orthoallyl phenol. Okay, here only the rearrangement should be takes place, but no change in the structure of the, no change in the formula of the atoms utilized as well as the formula weight of the reactant. So both are equal. So that's why it is called as 100% atom economy reaction. Next, take this addition reaction. So here in this addition reaction, we can take the propene. In propene, 3 carbon atoms and totally 8 hydrogen atoms are involved in the reaction and produce the product of propane. In that propane also 3 carbons, 8 hydrogen atoms are present. So the formula weight of the atoms utilized, it is equals to the formula weight of the reactants used in the reaction. So here the formula weight of the atoms utilized is 3 carbons, 8 hydrogens are produced as the product. And in the reactant, propene is having the 3 carbons, 6 hydrogen, and it is reacted with another mole of hydrogen. Totally 8 hydrogens are involved. So that's why it is called as 100% atom economy reaction. The next reaction is Diels-Alder reaction. In this Diels-Alder reaction, we can take the diene as well as the dienophile. Okay. 1,3-butadiene, it is reacted with, so this is called as 1,3-butadiene. It is reacted with ethylene. So 1,3-butadiene is called as diene and ethylene is dienophile. Then what happens? The rearrangement of the pi bond, so it is converted to cyclohexene. In the formation of cyclohexene, the total number of carbons, the total number of hydrogens in the reactant and product are same. So that's why it is also called as 100% atom economy reaction. Let us take substitution reaction. In this substitution reaction, we can take the ethyl propionate. It is reacted with methanamine and it is converted to N-methyl propionamide. Okay, as well as the byproduct of ethanol. So the total number of reactant is not equal to the total number of product because it releases the sum of the byproduct. So that's why it is not a green synthesis reaction. Look at this, the formula weight here given. So in this form, 87.106, it is the formula weight of the atom. So look at this. So here, the percent of atom economy is equals 87.106 by 133.189 into 100. So get the 65 percentage or 65.14 percentage. Okay. So that's why it could not called as a green synthesis reaction. Next, take the elimination reaction. In this elimination reaction also the byproducts are produced. So that's why this elimination reaction is not example for the green synthesis reaction. Okay. So this is the prevention of waste, first of all. The next point is about preservation or minimization of hazardous or toxic products. Okay. Look at this. The most important principle of green chemistry is to prevent or at least minimize the formation of hazardous products which may be toxic or environmentally harmful. Risk association with the toxic chemicals is a function of hazard and exposure. The end of the pipe laws attempt to control risk by dealing with the prevention of the exposure to toxic hazardous chemicals. Look at this, the prevention or minimization of hazardous or toxic products. That means if we can take the water-like solution. So this water-like solution could not produce the hazardous or toxic products. Then the next is about, in this process we can take the green solvent. So which are called as green solvent. The solvent selected for a particular reaction should not cause any environment pollution and health hazard. The use of liquid or supercritical liquid carbon dioxide should be explored. If possible, the reaction should be carried out in aqueous phase or without the use of a solvent. A better method is to carry out the reaction in solid phase. The one major problem with many solvents is their volatility that may damage human health and the environment. To avoid this, a lot of work has been carried out on the use of immobilized solvents. The immobilized solvents maintains the solvency or the solvation of the materials, but it is non-volatile and does not expose humans or the environment to the hazards of the substances. Look at this here, which are called as green solvents. Generally, in organic synthesis, we can take the benzene, ether, phenol. So, this type of carbon tetrachloride, these solutions are taken as the solvent. So, these are harmful to health. So, that's why instead of, and these are having the evaporating nature. Due to the evaporating nature, they are evaporated and enter into the environment and it causes some of the difficulty. So at that moment, what to do is, instead of these organic solvents, we can take the water-like solvent. So water, it doesn't having any harmful nature. Okay. So by using the water, if we can did the experiment, the water is taken as the solvent. At that moment, we could not get any hazardousness. Okay. So that type of solvent should be taken. And that moment we can prevent the toxic products also. Next one is ionic liquids. So which are called as ionic liquids. The ionic liquids comprising entirely of ions. Ion liquids are two types. So these ionic liquids are two types. The simple salts made up of single anion and cation, and the binary ionic liquids are salts where an equilibrium is involved. Okay, so these are called as ionic solvents. Binary ionic liquid, it is this type of having this type of structure. The reactions in ionic liquids are easily performed and no need of special apparatus or methodologies. Also, the ionic liquids can be recycled and this leads to reduce of cost of the products. Okay, if we can take the any ionic liquid, so it could not require a special type of apparatus and it is easily recycled. So that's why we can take the ionic solvents. It is better when comparing with the organic solvents. The next is fluorous biphatic solvent. Example is chlorobenzene and perfluorooctane. It is used in oxidation of alcohols into aldehyde and ketones. By this, that is 2266 tetramethyl piperidine oxalate. So this is the another reagent, that is PEG. It is called as polyethylene glycol. Okay. Then solvent less process. So solvent less process also we can take. We can take the less amount of the solvent and did the experiment. We get it is It is also called as green synthesis reaction. The next is immobilized solvents also taken, and these are non-volatile and doesn't having the explosive nature. So those are used in the reaction. Then the product, it should be act as a green synthesis product. The next uh, principle is energy requirement for green reaction. Okay. So what are the energy requirement? The use of microwaves and ultrasonic energy. If we can use the microwaves or ultrasonic, by using that we can minimize the energy. The energy consumption should be taken. Energy in this process, suppose at the normal preparation, the nitrobenzene we can prepare. That is takes for the some more time. But by using this microwaves or ultrasonic energies, so it requires the reaction takes place within the 5 minutes, 10 minutes, before 10 minutes. Okay, so that's why the energy also, energy consumption is not, energy consumption is avoided by using this green synthesis. The next one is selection of starting material. So the selection of starting material is the most important. Suppose we can take here this group, it is having the aldehyde functional group as well as the hydroxy functional group. Okay, so if it is involved in the oxidation, both the hydroxy groups and aldehyde group is involved in the oxidation and produce the acid. But we have to done the experiment. We have to oxidize upon the aldehyde. We could not hope that this hydroxyl group is does not involved in the oxidation process. At that moment, we can take what is that means we can take the one reagent. Suppose here we can take this benzyl chloride. So this benzyl chloride, it can acting as the protecting agent for the phenol group. Then it is reacted with this phenyl methyl chlorine. It is reacted with this group. Then this OH group is protected by the this one, and it is converted to this type of structure. So that's why the OH group is protected. Then in the next step, so this structure, it is involved in the oxidation. The aldehyde group is converted to acid, and finally, so the protecting group is removed by using the HCl, and this protecting group is eliminated and it is converted. Finally, the OH group is substituted. So we can select the starting material. That if we want to do the oxidation upon only one pot, so that type of starting material should be taken. So at that moment, we could not take the preventing agent. The next one is use of catalyst. The catalyst also play a main important role in the synthesis. We know that the catalyst facilitate transformation, and the conversion can be affected in short duration of time and consume less energy. Such reaction should be preferred with advances in the selectivity of catalysis. Certain reactions in green synthesis have become environment Okay, we can take this propene. Propene, it, it is react in the propene is converted to propane. In this process, in this catalysis, in this reaction, we can take the nickel as the catalyst. That means the propane and in the hydrogenation reaction or in the reduction reaction, propane is converted to propane. So in this process, we can take the nickel catalyst. So by using the nickel catalyst, the product should be produced within the short time. So in this condition, we can take the catalyst. The catalyst is the most important one. So these are the some of the examples of catalysts. The next one is chemical accidents and prevention. For example, the Bhopal gas is present. So in 1984, in the city of Bhopal, central India, a poisonous vapor burst from the tall tanks of the Union Carbide pesticides plant. The vapor was highly toxic cloud of methyl isocyanate among the 5 lakhs people. The people exposed to the gas, 20,000 have died, still dead, and 1,20,000 contaminated to suffer. So here we some of the accidents are produced by these chemicals. So we can avoid this type of chemicals which are produced out. At that moment, we can prevent the environment as well as the lives of the people. The next principle is inherently safer design. That means, suppose we can take this naphthalene 1-ol. Okay, so this naphthalene 1-ol, it is, look at this, then this ISD provides more rapid and reliable risk management and has the potential to make the chemical processing technology simpler and more economical by eliminating the need for expensive safety systems and procedures. ISD also address the immediate impact of design events on people, the environment, property, and business. Carbide synthesis without using a toxic reagent. Here, naphthalene 1-ol, it is converted to naphthalene 1-ine methyl carbamate in the presence of the 1,3-dimethyl urea. So we can take this intermediate. So in this process, the design of the chemical is most important. If we can design this naphthol 1-ol in the another way, it could get some of the difficult. The next one is the development of analytics technique. The strengthening developments of analytic techniques to prevent and minimize the generation of hazardous substances in chemical process. Analytical techniques should be designed that they require minimum usage of chemicals like recycling of some unreacted reagent for the completion of a particular reaction. Further, the placement of accurate sensors to monitor the generate of hazardous byproducts during the chemical reaction is also advantage. Okay, so these are the, so in this chapter we have the question that is in this is the important question. That is principles of green chemistry. So these 12 principles are there, as well as the brief study of the principles is important. Okay, shall I wind up the class?